Okay, what we're going to do now is we're going to look at some examples using these different properties of numbers that we've been talking about. So, quick little review of what we've talked about. We kind of agreed that reflexive, this one, symmetric, and transitive are they're good properties, but they're more for proving things like in a geometric sense and in other cases where you're doing actual detailed proofs. For us and for our purposes right now, we're really not going to use those. Next, substitution, we use that all the time. So that's just saying you can have equivalent expressions, you can write them in different ways for whatever's convenient. And basically think about it as doing simplification. Okay? And then additive identity, if you add 0 to anything, it doesn't change it. Additive inverse means that if you add the opposite of something to itself, you will get 0. So if you have 3, for example, and you add -3, you will get 0. Multiplicative identity says that if you multiply anything by 1, you will get that same thing. And like I said, a lot of these are kind of like duh, right? But they do have names. Multiplicative property of 0 just says if you multiply anything by 0, it makes it 0. And that's something you guys have known forever, but it does have a name. All right? Multiplicative, that's supposed to say multiplicative inverse, is when you multiply anything, so that's this A part, by its reciprocal, which is this part here. Sorry, I couldn't quite get the fractions to show up. You get 1, and that's what we're after here. Okay, and then you have your commutative property, which says that you can move things around, and you'll still get the same results. And then you have an associative property, which says that you can change the groupings within an addition problem or within a multiplication problem, and it won't change your answers. So let's go on Alex. Let's see if I'm still in here. Oh, it looks like I am still in. All right, so let's save this, and of course I'm kind of not completely 100% firing here today. So let's I'll get into this in a second, but I think the great thing about these properties is they slow us down for a minute and make us think about what we're doing. And that's really useful when we start solving problems in algebra, because there is a path to follow, right? And you can do them slightly different, but you wind up doing kind of a lot of the same things. All right, so let's look at these problems here. All right, so this first one, choose the property of addition that justifies the equation. So 2 plus 3 equals 3 plus 2. Well, that to me looks like they're just changing the order around. So think about change order, CO. So that should be commutative. All right, so let's put that one. 0 equals -8 plus 8. Well, it looks like you're adding the opposites to each other, and we call that, and that's an inverse property, and because we're adding, that would be an additive inverse property, and not the identity, because the identity is when you add 0. And then this one is just a classic example of changing the grouping, right? You notice the order's the same, but they change the grouping around. So we will call that associative, and we will give it a check, see if it likes our answers. Sure does. That's great. Let's move on. Let's try another one. So this one, 2 plus -2. Again, you have opposites you're adding together. So that would be your additive identity property. This one, they're saying x is equal to x if you add 0 to it, right? Well, that's obviously one of the properties of 0, and that's additive identity property, which is saying if you add 0 to anything, it does not change its identity. It keeps its value. And then this one, again, it looks like they just moved the parentheses from around the 2 plus the a to the 3 plus 2. Did not change the order of anything. They just moved the parentheses. So that would be associative. Partially correct. All right, so additive identity property, or no, sorry, I'm silly. That's additive inverse property. All right, good. All right, moving on. Let's see, what do we got here? Choose the property of real numbers that justifies the equation. So this is saying you're multiplying the same thing, but you change the order. Again, that's commutative, right? Commute, to move. 8 times a plus 4 equals 8 times a plus 8 times 4. This is one you guys we haven't talked about yet, but if it should look kind of familiar to you, you looked at 8's being distributed, right, to the a and the 4. So we call that the distributive property. Okay, this one, d plus 0 equals d. Well, that's one of those 0 properties, and that's that addition property, stating that if you add 0 to something, it does not change its identity. So it's additive identity property. All right, and then this one, you're multiplying b times its reciprocal. Remember, another name for the reciprocal is the multiplicative inverse. All right, so multiplicative inverse property. Okay, I apologize, I didn't know the distributive property ones are going to be in here. I got another one wrong. Row 1, your answer is incorrect. Because I said addition. It's commutative property of multiplication. Okay, that's what I like about Alex, is that you can make silly little mistakes like what I'm making, but it gets that you're understanding most of it. All right, let's look at one more here. 4 plus m plus n equals 4 plus m plus 9. I said n, that's 9. M plus 9 is what's in here, and then this is 4 plus m, so we just change the grouping symbols. So it would be associative property of addition. This one is a good one. It says you multiply anything by 0 and you get 0. So that's the multiplication property of 0, all right? And right there, multiplication property of 0. 1 times c equals c. Well, if you multiply anything by 1, you get itself. And that's another multiplication property. And itself, always think of your identity as yourself, right? So multiplicative identity. And then 5 times b equals b times 5. We just change the order around, so that's the commutative property of multiplication. Let's see if I can actually get that right this time. Making all kinds of mistakes here. All right, so as you can see, these are a lot of the kinds of problems you're going to have on Alex and everything. Not super complicated, just you know, go a little slower than I did so you don't make as many mistakes. But just, you know, if you kind of reason through them, you should be able to figure these out. All right, so good luck with these, and we'll see you on the next lesson.